Yes, children. So we come to the next session, that is the second order derivatives. Okay, the second order derivatives. So far we were discussing on y is equal to a function of f of x. We were trying to find dy by dx. Now, in the beginning of the session I told that dy by dx is the first order derivative. And now we are discussing on the second order. Now second order derivative is d square y by dx square. This is the second order derivative. How did we get the second order derivative? This dy by dx, y was a function of x, right? Y was a function of x. And we found dy by dx. Now this value that you get here, you will find the derivative once again. That is, you are finding d by dx of dy by dx. Okay, dy by dx is the first derivative. Again, you are finding the derivative of the first derivative, that is d by dx of dy by dx. This is equal to d square y by dx square. Okay, this is how the derivative comes. So, first order derivative is dy by dx, second order derivative is d square y by dx square. What will be the third order derivative? D cube y by dx cube. Now, you needn't study that. Okay, we have only first order derivative and the second order derivative. So, let's see how to find the first order and the second order derivatives. First order you know. Now second order derivative. Okay, I shall give you an example. Y is equal to x cube plus tan inverse of x. Okay, so this is one of the questions. Now let me find the first derivative. What is the first derivative? Y dash. Okay, now here d square y by dx square, dy by dx we termed as y dash. This will be termed as y2 dash. Or this one we also termed it as y1, isn't it? This can also be written as y2. Y2 says that it is second order derivative. Okay, coming back to our problem. So, x cube derivative is 3x square plus tan inverse of x derivative is 1 by 1 plus x square. Isn't it? Okay, so now what we are going to find is the second order derivative given by y2 dash is equal to 3 into 2x, x square derivative 2x plus what is the derivative of d by dx of 1 by x? What was the derivative? Minus 1 by x square, right? So here if I consider the entire denominator as x, what is the derivative of 1 by 1 plus x square? That is minus of 1 by 1 plus x square the whole square, minus 1 by x square. Now that of 1 plus x square is what? 2x. Okay, so that gives me 6x minus 2x by 1 plus x square the whole square. Am I clear? Otherwise here I have taken it as minus 1 by x square. Derivative of 1 by x is minus 1 by x. So if you want you can apply which rule? The quotient rule also. That is denominator into derivative of 1 is 0 minus numerator into, that is 1 plus x square. I shall write 1 plus x square into derivative of 1 is 0 minus 1 into derivative of this is 2x by 1 plus x square the whole square. This is exactly same as the same thing. Okay, am I clear? Now let's see another question. Okay, if y is equal to e raised to 6x into cos 3x, find y2 dash. That is the second order derivative. So what is our y dash? First function e raised to 6x into derivative of cos 3x is minus of sin 3x into 3. Okay, plus cos 3x into derivative of e raised to 6x into 6. Okay, now this is, I can write minus 3 into e raised to 6x into sin 3x plus 6 into e raised to 6x into cos 3x. Fine. So this is first function into derivative of the second plus second function into derivative of the first. Now what is y2 dash? Is equal to minus 3. Let it remain outside. First function into derivative of sin 3x is cos 3x into 3 plus sine 3x into 6 e raised to 6x. Okay, so it finished the derivative of e raised to 6x. So first derivative, second derivative is what I am finding. Plus 6 into e raised to 6x into minus of sine 3x into 3 plus cos of 3x into 6 e raised to 6x. Am I clear? Now I take this negative 3 inside. What do I get? 9 minus 9 e raised to 6x into cos 3x minus 6 3 is 18 e raised to 6x into sin 3x. Okay. Then this 6 comes inside, minus of 18 e raised to 6x into sin 3x plus 36 e raised to 6x into cos 3x. Okay. Now this is equal to, when I subtract this and this, when I simplify on this, I'll get it as 27 e raised to 6x into cos 3x. Of course, you have a 3 here. Okay, this time. Okay, 3x minus 18 e raised to 6x into sin 3x minus 18 3 raised to e raised to 6x is minus of 36 e raised to 6x into sin 3x. Now, if I need, I can take a 9 common out. 9 e raised to 6x into 3 cos 3x minus 4 sin 3x. Am I clear? This is what I am getting when I simplify and write the value of y2 dash. Okay. Now, let's see the next question. If y is equal to a sin x plus b cos x, prove that y2 dash plus y is equal to 0. So first let us find y dash. Y dash is equal to what? A into derivative of sin x is cos x minus b sin x. Derivative of cos x is negative sin x. Okay. Now y2 dash is what? A into derivative of cos x is minus sin x minus b into derivative of sin x is cos x. Now, if I take a negative out, what do I get? A sin x plus b cos x, isn't it? Now, this is same as what? Minus of y. Because y is a sin x plus b cos x. So, I will get this as, this implies y2 dash is equal to, y2 dash plus y is equal to 0. Otherwise, how will I prove this? Otherwise, I can just simply imply y2 dash plus y is equal to, what is that? Minus a sin x minus b cos x, then plus a sin x. Y is, this is y. Y is a sin x plus b cos x. Now b cos x minus b cos x, ax minus a sin x. So it gives you 0. So both the ways, either this way or this. This is an or here. Okay, both the ways you can prove that the required statement is true. Okay. Let's see the next question. Here, y is equal to sin inverse of x. Show that 1 minus x square into y2 dash minus x y dash is equal to 0. So, what is y dash? That is what I need to find first. So, y dash is equal to 1 by root of 1 minus x square. Right? Now, I square both sides. So, squaring both sides, what will I get? Y dash the square is equal to, when I square this, root and square nullifies to give me 1 by 1 minus x square. Am I clear? Now I cross multiply this. That is 1 minus x square into y dash the square is equal to 1. Okay. Now I apply the product rule. First function into derivative of this, that is 2y dash the square. If y dash is considered as x square, then the derivative is 2x, right? Here it is y dash the square, 2y dash, that of y dash derivative is what? y2 dash. Am I clear? 2y dash and derivative of y dash is y2 dash plus y dash the square, second function into derivative of the rest. Next, first function, that is 2x is equal to what? Derivative of 1 is 0. Now you look at this particular expression, 2y dash is common here and here. 2y dash, 1y dash can be cancelled. So, dividing with 2y dash throughout, what will I get? 1 minus x square into y2 dash minus 2xy dash is equal to 0. Sorry, 2 also get cancels. 2 with 2y dash is what I am cutting. 2 and 1 of the y dash cancel. X, y dash remains. So, 1 minus x square into y2 dash minus x, y dash is equal to 0. So, this is how I prove it. Okay. Now, let's see the next question where y is equal to cos inverse of x. You are asked to find d square y by dx square in terms of y alone. So, let's see how to find d square y by dx square in terms of y alone. So, that is something different. We have y is equal to cos inverse of x. So, what is cos y? Cos y equals x. Now, I find the derivative of x with respect to y. So, what do I get? This x with respect to y. Dx by dy is equal to minus of sin y. Am I clear? Finding the derivative of x with respect to y. So, finding the derivative of y here with respect to y, dy by dy comes. So, we needn't put y dash here. Am I clear? Now, what is dy by dx? Dy by dx is equal to, I have reciprocated this. This is minus 1 by sin y. I reciprocated the other side also. So, this is equal to minus of cosec y. So, now finding the second derivative. I have d square y by dx square is equal to minus of, what is the derivative of cosec y? Minus of cosec y cot y into what? Dy by dx. Because I am finding the derivative of y with respect to x. So, I have dy by dx. That is cosec y cot y, minus of minus becomes plus. What is dy by dx? Minus of cosec y. Minus of cosec y. So, what do I get? Minus of cosec square y cot y. Am I clear? Minus of cosec square y cot y. Did I get dy by dx in terms of y alone? Understood? Okay. Now, let's see the next question. If e raised to y into x plus 1 is equal to 1, show that y2 dash is equal to y dash the square. Okay. So, taking log on both sides. Taking log. What do I get? Log of e raised to y into x plus 1 is equal to log 1. What is the value of log 1? Log 1 is 0. So, log of e raised to y plus log of x plus 1 is equal to 0. Okay. Now, this is log of a, here it was log of ab, log of a plus b. Now, this is same as y log e plus log of x plus 1 is equal to what? 0. Am I clear? So, here log e value is what? Log and e nullifies to give you 1. I have already told this. So, y is equal to what? Minus of log of x plus 1. Minus of log of x plus 1. So, what is y dash? Y dash is equal to minus 1 by 1 plus x. Okay. Now, what is y2 dash? Second derivative of this minus remains outside. That is minus of 1 by 1 plus x the whole square. You have to consider this as 1 by x. Derivative of 1 by x is minus of 1 by x square. Minus is already outside. So, minus of minus is what? Plus 1 by 1 plus x square. 1 by 1 plus x square. Now, from here, this implies y dash the square is what? 1 by 1 plus x the whole square. Is it or not? So, taking into consideration this part, I can write this as y dash the square. Isn't this the proof? Got it? Yes. Now, I move on to the next question. That is, if y is equal to 3 cos log x plus 4 sin log x, prove that x square y2 dash, that is y2 plus x y dash is equal to 0. So, what is y dash? Y dash, or here in the question it is y1. Y1 is equal to what? 3 into minus of sine of log x, that of log x is 1 by x. Okay, 3 is a constant kept here. Derivative of cos x is minus of sine x. So minus of sine log x by x plus 4 into derivative of sine x is what? Cos of x. Here x is log x by x. Now x is common in the denominator. So I take that x this side. X into y1 is equal to minus 3 sine log x plus 4 cos log x. So what do I get? I get the expression like xy1 is equal to this. Now it is the second derivative is what is required. So x into derivative of y1 is y2 plus y1. Right? A derivative of x is 1 is equal to minus of 3 cos log x by x minus 4 sine log x by x. Okay. Now again denominator is common x, which is brought this side. So I get x square into y2 plus x into y1 is equal to minus of, from these two I took a minus 3 cos of log x minus of minus is common taken out plus 4 sine of log x. Okay. Now this is minus of what? Y. 3 cos log x plus 4 sine log x is equal to what? Minus of y. So that's the proof. Minus of y. When minus of y brought this side, you get it as plus y is equal to 0. There is a correction there in the question. It was plus y is equal to 0. So here it is y1 here. When I bring this y dash this side, x square y2 plus x y1 plus y is equal to 0 as it is required. Okay, the question when I wrote this plus y was not there. Now it is correct. Plus y is equal to 0.